Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Welcome to Cisco Champion Radio. Today we'll be talking about Wi-Fi 6 with Fred Niehaus. Our Cisco Champion hosts today are Roel Dionisio, Francois Vergis, and Gurpreet Singh. As for me, I'm Brett Shore from the Cisco marketing team, and I'll be playing the part of moderator. Fred, if you can introduce yourself and tell us a little bit about your role at Cisco, that'd be a great start.
Sure, be happy to. My name is Fred Niehaus, and I've been with Cisco since 2000. 2000 is when Cisco, about 1999, 2000, that's when Wi-Fi, it wasn't called Wi-Fi then, it's called something else, broke the 10 meg Ethernet barrier. When we busted 10 meg and went with an 11 megabit Wi-Fi device, we showed it to Microsoft. They go, oh, you guys rock. All of a sudden, this little company called Cisco Systems put their nose up in the air and goes, who rocks? And then they acquired us, right? So I've been with Cisco since 2000, day of acquisition, and my seniority all the way back to about 1993 I was doing wireless, so all that kind of holds.
Right. Now let's start with our hosts here. Francois, if you can give us a brief overview, who you are, where you are, and what you do.
All right. So I'm Francois. I work as a Wi-Fi engineer in Canada, and I also co-host a Wi-Fi podcast called Clear to Send with Roel. And so we like to just talk Wi-Fi all the time.
Awesome. Roel, your turn.
All right, my turn. My name is Roel Dionisio. I work in higher education doing Wi-Fi and also some wired networking. So I touch all aspects of the network. And yeah, I co-host with Francois.
Great. Gurpreet, your turn.
Sure. Hi, everybody. So my name is Gurpreet Singh. I work for AWAR in Canada, Toronto, and I'm mainly focused through wireless on different aspects of like we do education, we do warehouses, and pretty much touch different aspects. Wherever Wi-Fi fits in, we have a project for that.
Fantastic. Now we pass this back over to Francois to kick this off.
Yeah, sure. Thank you, Brett. So, Fred, you've been dealing with the access points and Wi-Fi for a long time now. When it comes to Wi-Fi 6 and the new stuff, what are you most excited about when it comes to Wi-Fi 6 and the core technology?
Well, you hear a lot about 5G happening, things like that. Well, if you think about what Wi-Fi 6 is, about 2 years ago, sometimes people would say, if I turn off my Wi-Fi on my phone, I just use my cellular, it seems to be faster. Why is that? Because the cellular industry, they buy those frequencies for millions and millions of dollars, so they use every microsecond on the air they want it to be efficient, right? Well, Wi-Fi 5 or .11 AC was all about very high throughput. Now, I got to go really fast, but it had nothing to do with latency, right? And the thing is if you have latency in your network, you're waiting for that screen to refresh. You're waiting for that voice that's choppy, right? And what Wi-Fi 6 gives you is a new thing called OFDMA, and it cuts latency all the way down. I can explain a little bit how that works. But that's one of the great things about it. The other thing is IoT and 2.4 gig. A lot of times they say 2.4 gig is a junk band. We do everything at 5 gig because you only have 3 channels, 1, 6, and 11. There's a new thing called BSS coloring that allows you to basically channel reuse and tells the client, look, I'm going to reward you if you turn your power down. The worst thing in a Wi-Fi network is clients that are transmitting at the most highest power possible and making everybody wait for their turn to talk. If I can reward a client and say, lower your power, I'll let you go now. And if I can create coloring like that, I can do that. So the things in Wi-Fi 6 are basically, if you think about 5G, we're ahead of the game with 5G. We've got a lot of the things that's in 5G is in Wi-Fi 6 and available today. In fact, we've got products now that we're releasing that address that issue.
Okay, awesome. Yeah, I was actually attending a talk on 5G this morning, and the big deal was latency. Like they wanted to reduce latency, and they were talking about that. Okay, so OFDMA and BSS coloring, it's pretty much the top on the top of the list for you in terms of.
It is. If you're IoT and your whole life lives on a coin cell, if you're a small battery, then you're worried about battery savings, right? There's a lot of things in Wi-Fi 6 with this target wait time where I can basically put something to sleep and wake it up at a later time. A scheduling. Yeah. So if I'm a telemetry, a device, and it's a coin cell, and maybe I'm doing temperature, I'm keeping track of temperature. What I might want to do is put a device to sleep for that day, wake it up either one at a time, give me the temperature, give me the telemetry, or wake them all up. Well, with Wi-Fi 6, I can do a target wake. I can wake you up as an individual, or I can wake up an entire group of people, get their data, shut them back to sleep again. So battery life is a big deal, and so is OFDMA and latency.
Okay, so when you read the draft from the IEEE and the 802.11ax specs, you can see that the IEEE is introducing a lot of new features to the Wi-Fi 6 iteration of the protocol. Which of these features are implemented in Cisco access points today? Can you talk about that? Which one which one aren't, and why?
Sure can. A couple things. I want to break down a little bit for people to understand. You hear this Wi-Fi 6, Wi-Fi. How come I never heard about Wi-Fi 5 or Wi-Fi 3 or 2 or 1, right?
Yeah.
And I wanted to just break it down a little bit and say that you mentioned IEEE. The IEEE writes the spec, the 802.11ax spec or the AC spec, right? The Wi-Fi Alliance takes elements of that and decides what they're going to test for interoperability, okay? So when your question is, what are we doing? We obviously want to put the things in our new AP that the Wi-Fi Alliance is testing for interoperability. Okay. So let's look at those. Things like the OFDMA is very important. Things like multi-user MIMO, the ability to send data to multiple clients at the same time is very important. So MU MIMO or multi-user MIMO happened in .11ac or Wi-Fi 5, if you want to rewrite history and go backward. That was in there in Wave 2, the last part of it. Very few clients are capable of doing multi-user MIMO. With Wi-Fi 6, it becomes table stakes. It just happens. So that's very interesting. When you look at some of the elements of IEEE has something called OFDMA in the uplink and the downlink. Okay, and what they're saying there is that, to give you a quick overview of OFDMA versus OFDM, if you think of a channel, say 20 meg wide, and a bunch of single little micro channels or carriers that are in that 20 meg segment, with OFDM, it takes those micro carriers and says, I'm going to put, Bob's data on one little carrier and Bill's data on the other little carrier, until I fill up and send it out. The problem is if Bob's data or your data is just one little chunk, I waste the entire carrier sending your little chunk out, right? OFDMA says I'm going to take those little subcarriers, I'm going to make lots more of them, and I'm going to put multiple people on them, multiple people's data on them. And this is how the latency is reduced. The reason I'm telling you this story is to tell you that you can do that in the uplink or the downlink, meaning downlink from the AP down to the client or from the client up to the AP. Well, some of the access points that are early to market, like, for example, we have an 8x8, it does not do OFDM in the uplink because the chipset just doesn't do it today. We've got other APs that do. We have 3 APs in our product line today, and 9115, 9117. The 15 is a 4x4, the 17 is an 8x8, and then we have a cool thing called a 9120. Hopefully we'll have some time to talk about that one. But those are the 3 that are out of the gate today. Out of those 3 out of the gate, only the 8x8 will have trouble in the Wi-Fi Alliance getting certification because it doesn't do OFDMA in the uplink. The other 2 do, and it's a piece of the chipset's why.
Okay, so the chipset is not ready yet? That's what you're saying?
Well, what I'm saying is the 8x8 that we used on this particular AP wasn't ready. See, the thing is there are a lot of chipsets from our competitors and even our sister companies and things that have products that don't do OFDMA in the uplink simply because they wanted to be first to market with a product and the chipset didn't have it. And this is the problem we have with 8x8, right? Do I want to come out with a product today that's 8x8 to satisfy requests for proposals and to give somebody something early, or do you want to come out with something that's a standards-based? We are a standards-based company, so we will follow up another 8x8 that will do it in both directions. But there's a lot to be gained by an 8x8 even without it.
And the chipsets that you're referring to, though, they're not Cisco chipsets. These are...
Well, the Wi-Fi chipsets that are out there, okay? We can say they're not Cisco chipsets. Well, yes and no, okay? In the past, we've worked with Marvell, and who's a company that does chipsets, right? And we walked to Marvell and said, look, we want our own custom silicon into your chipset. We don't weave it around and make things like clean air and high-end things that we haven't done before. The problem with that is that, in any point in time, certain technologies, companies are farther than others, right? And I have no technology religion. So I will use a Qualcomm, a Broadcom, a Marvell in a heartbeat to satisfy what our customers want today if they have it today, right? And we've kind of hedged our bets a little bit on that 9120, and I want to talk about that in the RF ASIC in a bit, why that matters when you look at different manufactured chipsets.
So the 9115 is using Broadcom, and then 9117 Qualcomm?
Well, and I don't really try to get wrapped around too much of who's making the chipset because it's temporal. In other words, if I can rev that chip in the manufacturing cycle, change it, make it better, whatever, I'm going to improve it as we go on. Or we'll do it with new models.
Okay, and I think for us, engineers, that's what's kind of hard for us because we hear Wi-Fi 6. The customers hears Wi-Fi 6, and they think like Wi-Fi 6 is kind of like
the next best thing.
Right.
It'll fix everyone's problems,
yeah.
But they don't understand the technicalities of what's under the hood, right? And what's the possibilities.
Oh, absolutely. Because like when you look at an 8x8 AP, and you're like, well, why do I need an 8x8 AP? What's wrong with a 4x4, right? Well, if you have an 8x8 AP, that's 8 receivers that can hear that weak client versus an AP with only 4 receivers that can hear that weak client. Right?
And that's a good point because a lot of customers actually go and say, well, if most of my clients are 2x2, why do I need a 4x4 or the 8x8?
Because the 4x4, 8x8 are all that many receivers that can hear the weak signal. In other words, years ago, you had one radio and 2 antennas. If I had a problem on one antenna, I just switched the antenna, for multipath reflections. Now it's like, just throw radios at the antennas, and then when you do something, all of them hear it, and then they just pick it out of the noise much better.
So let's talk about the Cisco APs, right?
Okay.
So you guys introduced new Wi-Fi 6 APs. How could we compare the new models with the previous generation of APs, 28, 38, 15?
Okay, you mentioned 28, 38. For years, we've called them Cisco AeroNet APs because we've been making Cisco AeroNet APs since 91 and Cisco since 2000. The AeroNet brand is a very important brand. Okay, I've got a lot invested in that, having worked in it for as long as I have. And when Cisco said they're going to change the name to Catalyst, I'm like, why would you do that? And
the OS is changing, right?
Well,
that's probably why.
Part of it's the OS, and part of it is also, someone said to me, Fred, what is Cisco's very best product line? Catalyst. So why wouldn't you want your very best APs to be called Catalyst? And by the way, the same people that make the Alfa Romero car designs and all that Pininfarina, we're going to hire them to redesign these access points and make them smaller, make them look better. We're going to put more money into the AeroNet, now Cisco Catalyst line from other sources other than just us guys in Richfield, Ohio. We're really doing a lot of things. So I'm really excited about it.
Okay, so can you compare the previous generation to the new one and how?
Sure, if you look at the lineup like 1800, 28, 38, the first 2 new APs out of the gate, the 9115 and 9117. Those are like the 1850 and 1830 series APs. They're early to market and they're standards based. Okay, which means whatever's in the Wi-Fi standards, we're going to put into this AP, and they're early to market. Now, the 9120 is more like the 2800 series. It's not completely highest end, best in class, but it's got lots of the cool best in class things the 28s and 3800s had. Things like dual 5 gig and many other features.
So could we expect a new Wi-Fi 6 AP to replace the 3800?
Well, or the 4800 you should
or
ask
the 48,
me about,
okay.
Right?
Yeah.
So the 4800, let's talk about that for a minute. The 4800 is the very best access point we make today. Okay, it's got hyperlocation, can find you. It's got, it can do dual 5 gig. It's got the clean air Cognito chipset built into all of that, right? When it also has something called client link. Client link is a beamforming mechanism to send a strong signal to a legacy client, a pre-AC client, like a .11n client, for example, right? So that's a really high end. That goes all the way to our highest end AP. So, you know, as far as a future thing goes, okay, the first one is the 9120. Down the road, we will have other ones that are more like that 4800. But right now, they're not released. And I don't want to talk too much about futures because we've got a really cool 2800-like version.
Yeah, let's talk about this one
today.
Okay, let's talk about it. 9120.
Yes.
Okay, so can you just explain what's very cool with this new AP?
One of the questions that was asked earlier is he said, well, what chipset are you using? Well, let me talk about Wi-Fi chipsets for a second, okay? There's something called DFS, where if you hear a radar signal, you have to get off the channel, right? We've designed in the 9120 a special software-defined radio that we call an RF ASIC. Well, what's an ASIC? ASIC is application-specific integrated circuit, but basically what it is it's custom silicon to do unique things. So rather than work like we did before on previous products with Marvell, where we took our own IP and put it into their silicon, we've done our own software radio that's totally separate. Now, why would I care about that? Well, think about this. Marvell might do one kind of DFS algorithm. Qualcomm, Broadcom, they all do different ones. Well, if you've got a radar signal, I want our RF ASIC to trump that, kind of like an AND gate, right? So it's like, okay, I got a false detect of a radar signal here from my Wi-Fi chipset of whoever manufacturer I happen to have used at the time. What if it's not true? What if it's really not a radar signal? The RF ASIC goes, I'm a full spectrum analyzer. I'll look at that thing. I'll determine whether that's really interference. And if it is, then I'll take you off the air. Otherwise, stay on the air. So resiliency and keeping it keeping that performance up is what that's all about.
So it reduces the false positive and the downtime.
And the downtime, especially like if you have certain frequencies in Europe where you have to be off the channel for 600 seconds, okay? Put that RF ASIC over there and let it go do that stuff with your software radio while you're servicing clients on a radio channel you can use, and then pick it up later. So that's only one small advantage of this RF ASIC. The other thing about the RF ASIC is because it's a separate radio altogether, it can do whips and WIDs and security monitoring and all of that as well. And the 9120 versus the other two. Remember, the first two I told you were like the 1830, 1850 series. They are entry level. The 9120 has things in it like a Zigbee gateway. It has the ability to do dual 5 gig like the 3800 and 2800 does. So if I could do an 8x8 AP that's a standard-based 8x8, or I could take a 9120 with the RF ASIC and all that advantage and take the two 5 gig radios and do dual 5. So basically, I'm doing 8x8 just on two different channels, and I'm able to do that and reduce the spectrum utilization on each channel.
So the RF ASICs, it's a specific radio. So it's not serving any clients, but it's used to pretty much optimize everything else.
Correct. The RF ASIC doesn't serve clients, but unlike the previous RF ASICs that we have done on like the 4800 and things, we can transmit on that antenna too if we want. So I can do client containment, perhaps, with that radio rather than waste time with a servicing radio. Also, there's some things that are hardware-wise. When I tell you that's a full spectrum analyzer, think about this. If you shut your eyes and you hear a male voice and a female voice, you can tell the difference, right? But it isn't until you know me and those in this room that you have to kind of learn that's Fred's voice, that's his voice, So think about if you had a full analyzer and every radio signal on the air has voice, and you could machine learn that voice, okay? Think about the thing about this, and this is a software future thing. The reason I'm even talking about it right now is because the RF ASIC is hardware capable of this, okay? But think about this. Like Cisco's encrypted traffic analysis. I can't see the traffic, but I know I'm looking for malware. If I could look at a signal, two Wi-Fi signals, without caring about MAC address, not caring about anything, and go, you're this one, you're that one. If you try to spoof him, I know who you are before you've even really done anything on the Ethernet side.
So is it what you call RF signatures?
Yes.
Okay, all right. So what about packet captures?
Packet captures are much like with the 4800. The 4800, you can take that third radio on the 4800 and do packet captures while you're servicing clients.
Okay.
We can do this with the 9120 as well.
Okay.
The only advantage with the 4800 is because it has hyperlocation, you can do a packet capture and stitch it all together with where you are on the map, and you can't really do that with the 9120, but you probably do that with the future.
And could you do like smart packet capture? Like if you detect something that's not going right, you just start capturing some packets to try.
Absolutely. That is whole in the Cisco DNA.
Yeah. We've heard about it this morning.
And again, the product. It's very when you make a product, you're making a piece of hardware, right? You've got to make the very best hardware because the software comes along later, right? I mean, if you're a software programmer, you can't write a cool program if you don't have the hardware to work with it, right? So we've just kicked out this really cool new hardware, right? As we start software doing things with it, some of the questions that you're asking all of a sudden start to become really granular. We're able to do all of those things, but we have to get time on that chipset.
So talking about software and the different version of iOS we're dealing with now. So we have iOS XE with the Catalyst line, and we have AirOS. So will all of these new features will be supported on both platforms? Or
well, iOS XE I believe is where we're going with that.
Okay.
To be honest with you, I'm a radio hardware guy. I design the APs and write the deployment guides. So software is not my thing that much.
Okay.
Okay, because all of my questions were going to go to the software, but but I do like the idea of going to iOS XE because of the capability there, the programmability you have there. But I wonder if that's also going to be are we going to have anything available or access to the RF ASIC as well? Like, are we going to be able to have like API metrics, access or something to like gather these metrics or even act on something?
We have a program. If you roll back time a little bit, when we had the 3800, it had a module, right? We're not done with modules, but anyway, the module has something that we call the Cisco AeroNet Developer Platform. Okay, and so if you were going to make a module for the AP. And we have like Imago Tag and other people have made like electronic price shelving modules, right? Our AeroNet Developer Program is, this ADP program is where we connect you for when you're building something, right? And the RF ASIC may very well dovetail into that as we get some time on the AP. Remember, we're just coming out with this new 9120. The things that are in the RF ASIC, are because it's a completely software definable radio, and it's got. I mean, this actually looks at the data at the IQ layer, the very lowest layer, and feeds it in. So there's nothing on the RF we can't see with that RF ASIC, right? So the question is that you have is, are we going to pull that out and make that available for third parties? And I think so. In fact, and I think it's a matter of putting time into that and getting that spun up.
Yeah, because I think there's a lot of possibility there, right? You have this RF ASIC that can do some sort of fingerprinting, RF fingerprinting or signatures, as you say, and then even collect data from other people to create more accurate signatures and be able to quickly show a signature out there and go, okay, here's a signature coming from this specific camera, and someone could probably have the same type of camera but not know how to pick up on that signature until it's shared somewhere to like the DevNet.
Right, exactly.
Zone.
I think we need to open up DevNet and the AeroNet Developer Program, which is DevNet, by the way. It's tied in with DevNet. I think we need to build that up because it's kind of like if you look at the Yang models and things, people want to be able to just pull and do what they want out of things, and that's a phenomenal radio that I just, I'm looking at that radio going, God, we need to open that up if we could, because the things that you can do with it are amazing.
What was it like creating a radio like that? You say you're a hardware guy, so what's involved with creating a radio or a piece of hardware that's vastly different from what's out there today?
Well, it's really challenging because one of the things, if you look at the new APs that we have, the new .11ax APs or Wi-Fi 6 APs, every one of those, unlike the 4800, has some mode that it can run in at 15.4 watts, at the lower 802.3 AF power, right? So the first thing that happens when you design an AP is you got to think, well, am I going to run on AF 15.4 watt, or am I going to run on AT 30 watt, or am I going to run on UPOE? I need more than 30 watt, and then so you're building this AP, and you tell yourself, okay, do I want to put a USB port on it and let people take power out of it, right? Well, do they need that? That's the first discussion, right? Then the second discussion is, well, it's table stakes. The competitor's got one. I got to have one on mine, or I'll lose the RFP. Blah blah blah. Well, that's 2 watts that you give up right out of because whether you use it or not, that port needs 2 watts, okay? And it is reserved. You take that RF ASIC, that separate, complete, full spectrum analyzer radio. That's another 2 watts. Things take power. Then not only do things take power, you're going to put multi-gigabit Ethernet on there. Well, that magnetics takes power too. So the next thing is you have a thermal problem. As things that take power, things get warm. Turn on light bulbs, you got heat, right? So now you got to get rid of that heat. Well, you want a big hunk of aluminum on the back of it? We did that on the 3800s and the 4800s because I want that AP to run in a cold Kroger freezer in a place in a steel mill where they're pouring hot molten iron, and I want that AP not to fail, right? A lot of people say, well, a lot of people can make a lighter AP, and then they well, you're just going to put it in the carpet area anyway. Hell with you, And if they put it in a Goodyear tire plant in Indiana, and the robots are running the tires around, and the AP fails and it's 35 feet in the ceiling, the answer isn't I'm going to give you another AP and a cute jacket or a pair of socks to go with it. You need it to not fail, right? So
you got to add some sort of durability.
So our products, a lot of times, people laugh. Is he going to pour water on it? I'll do a talk and I'll pour water. Throw the darn thing across the room, because I put my paycheck on the fact I can throw that across the room, pick it up, and it'll still work, right? And if you go on eBay today and look at an old 350 AP that we did in 2001, go buy one on eBay. The damn thing will still work. We'll only run 11 meg, but it works. We don't make them to fail, and that's another problem in the hardware design. How do I design this thing so it doesn't fail, but doesn't pooch out and get too ugly, doesn't get too heavy? All of that's a balancing act, So I'm kind of proud of the things that we do with these products to keep them, as robust as they are.
So Fred, what about 9120? I do see that's pretty good though. It looks much nicer aesthetic-wise. Is it still that durability, all that stuff that was in the previous ones will still...
Yes, but... And what's the but? It's got a but. Damn it, it's got a but. Yes, but if you take the 9120 and you look at it, and you take, another AP, some of our APs have dual Ethernet ports on it. There's no dual Ethernet port on that 9120, is there? I jettison that port because I don't want the heat and I don't want the weight, right? The other thing is local power. That 3800's got a power jack. I can just feed it with 48 direct into that. I got rid of that on the 9120 because if I put a power supply in there, bridge rectifier, capacitor, things I need in there to do that, I'm getting heat, I'm getting size, I'm getting weight, and I'm getting aluminum. So yes, we've cut back, we've made some point changes going, if you need local power, you can just go get yourself a power injector. They're not that expensive. We're done with this. We're not putting it in the AP, right? So we've made those kinds of design changes, but none that I think really impact the customer. Not the customer that cares about quality, at least.
Did you design a 9120 that supports external antennas?
Yes, but it's not out yet.
Okay.
And let's talk a little bit about external antennas. Okay.
Yeah.
We have this connector that we call a DART connector. It's a little square box antenna, antenna connector. It first found its way into 3800, and what's nice about it is if you look at a typical AP with 4 connectors on the top of it that the dipoles screw to, right? By default, those are your antennas on an external unit. So when you take a unit out of the box and put the dipoles on it, it's dual band, 2.4 and 5 gig. If you take a 9120, the new external model, or you take say a 3800 and you plug the DART connector in, the XOR radio inside, in other words, that AP by default is 2.4 and 5 gig. If I plug a DART in, there's another radio, there's 2, 4, or 5 gig that now flows out the DART. So if I decide I want to use 2 dual 5 gig if I want to do dual 5 gigahertz APs, I use the Dart, I plug it in, and now I've got a Dart antenna external for 5 gig and an internal on the top of the RPT&C connectors. And so I can have an omni and a directional, or 2 omnis. I can mix and match, do whatever I want. 9120 will be the same way.
Okay. And the Dart connector will be used as well then?
The Dart connector will be used on the 9120.
Okay.
The thing about the Dart is we're improving upon it. Okay, we are creating. There's a bunch of antennas that are popular with Cisco, like the 2566, the 6 dBi patch antenna. Right? We're going to put a 2566 with a Dart on it. Okay, so rather than have to plug in a Dart adapter and screw things in and all that, I can just take that antenna, jam it right in, and I'm done. And I don't really talk about futures too much, but I've as you start to look at these 8x8 APs wanting external antennas, I might have a dual Dart in the wings. just let you know that, and as I start doing hyperlocation and needing more antennas and things, that Dart plays a big part of it. In fact, one of our partners right behind us here is Exceltex, and they've got a small patch antenna with a Dart on it already. So we're actually working with partners to get that Dart antenna and self-identifying antennas up off the ground.
So is it like the Dart, is it like an open connector, or is it like proprietary to Cisco?
Dart, I put an acronym on Dart. I call it Digital Analog Radio Termination. Digital because there's 16 lines of digital on that Dart connector, and there's 4 analog antenna ports on that connector, right? It's actually an Amphenol proprietary connector. We've worked with Amphenol for a long time, and we kind of own that connector for the most part. Okay. And we're trying to make that antenna connector the antenna connector for things like Wi-Fi 6 antennas and things. So we're adding a little bit of smarts to it. And again, back to the AeroNet developer program, we're trying to feed into that so that if somebody does want to make an antenna with a Dart on it, the nice thing about that is as we do self-identifying antennas, if I know you plugged in an outrageously high gain antenna, 13 dBi or something, on an AP that only supports 6 dBi, I'm hoping in software to have the Dart auto-recognize the antenna, see that its gain is too high, set the antenna gain on the AP internally to fix it.
So is it a smart connector?
Yes, it is.
It's a smart Dart.
A smart Dart. There you go. Exactly.
All right.
You got anything else, Cooper?
No, that's all. Like pretty much Fred covered it all.
Yeah, it's a cool time. I mean, it's a I'll talk about some things in general till we run out of however much time we got here. But it's cool because not only are you bringing the latency down, or you're making things all better, but the thing is if you take an AP today, like a 4800 with that client link and everything else, it's a rockin' AP today and will serve you for a couple years, really. When you look at .11ax, okay, the reason these products are out early is if I'm a college or university, I don't want to say I'm running Wi-Fi 5. I want to say I got 6, I got the latest one, right? But think about this. The 4800 with client link, and so we pulled client link out of the AX APs, by the way, because it only helps legacy clients. When you go to AX, I want you to get to AX. I don't want to keep trying to support these legacy clients. I want you to jettison them, because your network won't be improved with AX till you get clients at least 30% or more in your network. Because all of these cool things with OFDMA and latency and everything, it doesn't help if all your clients don't know how to do multi-user MIMO, don't know how to do OFDMA, So you need to get clients there, and we think that clients are going to get there faster than they did before. Because, usually it takes 3 years to maybe even 4 years. How long was it before you went from .11n to AC? And how long did it take to go from AC Wave 1 to AC Wave 2? There's a couple years in those things, right? So we want these AX APs or Wi-Fi 6 APs out there now to support the clients as they come up, and we're working with partners like Samsung and others, to make sure that seamless roaming happens from 5G right to Wi-Fi 6, and to make sure that those chipsets work really well with Wi-Fi 6.
Can you go into any detail of how you do the testing, like what it's like to?
When you're working with,
I'm sure you got hundreds of those devices.
We do, and what's funny about that is we have we do Cisco Barcelona and Mobile World Congress, right? And Jim Florwick's one of the guys that does that NOC or that center, and he tracks client use every year, right? And the thing is client throughput in terabytes goes up and up and up and up every year, right? But if you look at how the throughput went up, and then you look at how the technology changed, throughput went up when we went from N to AC, the efficiencies in the RF kept the channel utilization the same. So while we keep moving faster, more and more terabytes, the channel utilization, how long you're on the air, seems to remain fixed, right? And that's the idea with .11ax or Wi-Fi 6 is have terabytes of data flowing in a big place and have your channel utilization the same and your user experience better.
So will Wi-Fi 6 fix all of our Wi-Fi issues?
No. Let's put it this way. If you have a bad design already, Wi-Fi may help that. But what I would tell you to do, if you're looking to deploy Wi-Fi 6, look at it and say, now's a great time to reevaluate what your network looks like today. Forget about Wi-Fi 6 just for a moment. Does this network suck now? Do I have dead spots? Do I have things that are not good now, right? And think about that as you lay out the Wi-Fi 6 new APs. Maybe you need a few more than you thought, to cover those areas, but, reevaluate things. Assumption is the mother of all somethings. You can when you assume it, two things. You don't want to assume. You want to rethink about stuff. And confidence is really the feeling you have before you fully understand the situation. So don't go into it too confident. Go into it and think about what I want to do and do it. There's a lot of things. Ekahau, one of our partners that are here today, they've got site survey utilities now for Wi-Fi 6. A lot of things out there to help you, and we're constantly on the writing deployment guides and papers and things.
So Wi-Fi 6 won't fix bad designs for sure. Obviously,
no, it does, but it will make the user experience better. If your latency goes way down and you're able to get on the air faster, and even 1024 QAM, it has been introduced in Wi-Fi 6 too. So now you've got more complex modulation. So with a one channel, one radio, the thing is a lot of times you only have in a device one radio because of battery life. If I have more complex modulation, 1024 QAM, I instantly get a 30% bump in throughput just with 1024 QAM, which is MCS 1011 or whatever it is. And that helps you because you actually can get those cells, reasonably well. So, your overall speed goes up, latency goes down, and your experience is better.
In your experience with the testing, how likely is it to get 1024 QAM? I've heard people say that's probably never going to happen because you need the AP directly above you. You need to be that close.
You have to be immediately close by.
But that changes because of OFDMA.
Well, it changes because, here's the thing. OFDMA, if you pick a channel, remember you can bond. You can go 20 meg, 30, 20, 40, 80, and 160 meg, whatever. If you're in a 20 meg spectrum, and now you have much more subcarriers because you put them together, those subcarriers are smaller, so they're more easy to be heard, and they can run higher power in many cases.
Your SNR probably goes through is much better.
Exactly. So I can use that really complex modulation and get a decent cell. In fact, I've got a presentation on Wednesday morning, and I've got some plots that I show what it looks like with 1024 QAM in a cell, and it's actually doable. It's quite doable.
That's interesting.
Looking forward to that.
And so OFDMA, if we want to test OFDMA at home, how many devices do we need to be actually able to?
Well, it's funny because that's if you go back 10, 15 years, okay, people would complain, hey, I take a client, I power it up, and I connect to a Cisco AP, and I'm right under it. And I walk 300 feet or 20, right underneath another one, and the damn thing doesn't roam. Why? And I'm like, well, move some traffic. Moves instantly, right? Well, the point is that if I'm connected and I'm not moving traffic, why would I want to cause a roam event and make RF noise? I wouldn't, right? And the case with OFDMA is if I've got one client and I got OFDMA or I don't have OFDMA, I don't have enough there to see a difference. In fact, I'm going to turn around and say, you know what? I got a Wi-Fi 6 and a Wi-Fi 6 client. I got them on a table, and I got an OFDMA or an OFDM Wi-Fi 5. Hell, the Wi-Fi 5 is performing better than the 6. Yeah, really? Well, why don't you load up about 30 to 80 users on that AP, and all of a sudden, damn, this Wi-Fi 6 rocks. But, again, you got to have at least 15, 30 users on an AP hammering it really hard to see OFDMA to even be worth anything to you.
Okay, so do you guys have a threshold in the AP that tells the AP, okay, now you start using OFDMA?
No, it's all on a per packet. The AP looks at the client, what's the client's capabilities, and I'm going to return to the client what it can send. So if the AP, if the client supports OFDMA, we're sending OFDMA out. If the client doesn't, we send OFDM out.
Okay.
And we have to contend. It's almost kind of like having that noisy old .11b client that wants to make noise and be on the air all the time against this really rocking one, right? I mean, it's not that bad, but my point is that you'll want to get to Wi-Fi 6 clients for that holy grail promised happy hoo-ha. Everybody's always telling you, buy this, it's better and faster. Yeah, right. Well, to see that, you need Wi-Fi 6 clients. You really do.
Which means we'll see a big improvement in situations like here in a conference or in lecture halls, very high density environments.
That's really what it's for, or even school systems. You got grade school and you got kids in room after room after room and overlapping and all that, and they don't have an RF guy that can do that kind of stuff. All of a sudden, some of the benefits of Wi-Fi 6 kind of go in there and band-aid over the problems that a good RF engineer wouldn't have done, right? I mean, I'm not saying that's a good thing, but the net take is the person who has very little AP experience can put a Wi-Fi 6 in a high-density area and go, wow, this is much better, and they can actually see it.
So do you think we'll have Wi-Fi 6 deployed next year at Cisco Live? Do you think we'll have
That's
the
our
APs?
Goal. We had Wi-Fi. Okay. We had some early Wi-Fi 6 in Barcelona, and we've got some early Wi-Fi 6 here running. So
yeah, I'm talking like the full-on venue with external antennas and.
Well, we'll see how far the clients get. The clients are supposed to happen in 2020, early 2020 is when they start appearing. See, the thing about it is, if somebody told me like right now, I'm going to buy an AP. Should I buy a Wi-Fi 6 AP or should I buy one of them 4800s that Cisco calls their best in class, best in breed, right? And I would look at you and I would tell you, well, what do you got now? And what I mean by what do you got now is, do you keep things for 5-8 years? I mean, if you don't buy APs regular, look, I buy something and then I live in that world for a very long time. I would say buy a Wi-Fi 6 AP now because you're not going to get that opportunity. But if you told me, you know what, in 2 or 3 years I'm going to be buying another AP anyway, I wouldn't know what to tell you. I'd say, you know what, maybe I'd buy that 4800 because right now that's the very best and does legacy client, does it. Your experience will be better with a 4800 until you get Wi-Fi 6 clients in there, right? So it really becomes kind of a vexing thing. It's damn hard to beat a 4800 or 3800 or even a 2800. Those are really rocking good APs. And these Wi-Fi 6 APs, they're the first two, the 9115 and 17, they're early out the gate standards based, so they're more like the 1800 series than they are the 28s and 38s.
Can you talk about WPA3 support and OWE? Are these
not a lot because I don't follow it too much, but WPA3 comes with Wi-Fi 6. So all of the new APs support WPA3.
Is it going to be a requirement at the Wi-Fi Alliance to get the Wi-Fi 6 stamp?
WPA3 is a requirement.
Okay.
Yes.
That's good.
The only thing that some manufacturers have had problems with is the OFDMA and the uplink, as I mentioned before.
Yeah.
Because some of the early chipsets didn't support it because the spec. And this is the same like when you look at multi-user MIMO, right? Multi-user MIMO, people confuse the two. They're totally different. But with multi-user MIMO, when I talk down to clients at the same time, that's downstream multi-user MIMO. Upstream multi-user MIMO is in the spec, but that may be like an Wi-Fi 6 Wave 2 kind of thing. And in other words, it's very hard to do multi-user MIMO because I have to find users in different parts physically in the area because I'm going to beamform to one and anti-beamform to the other, and it's very complex. But my point is those things. The WFA, the Wi-Fi Alliance, is saying, look, multi-user MIMO has to be in there, OFDMA and uplink and downlink must be in there. So we got one AP that's got a little problem there, and like I said, almost everybody has that problem because the chipsets didn't think they'd have to do it.
I guess to wrap up, what are you looking most forward to? Like what's coming out that, or with the APs out, what are you most excited?
Having that completely software-defined radio in that 9120, that RF ASIC, okay, that radio isn't being used to its full capacity in the 9120, meaning that radio has the full capability of hyperlocation if there's the right array and the right hardware behind it. That RF ASIC has the ability of doing things that nobody else could even dream of doing, because you can't, if you don't have it in the hardware, you can't make the software do it, right? So I'm looking at that RF ASIC thinking, man, I'm going to be able to do things with that I can't do with any other AP. And then when it comes to the competition, it's like, I have everything they have and I have this too. And it's like, damn, and it takes good RF design to do that. In other words, if you want to design something like that RF ASIC, even things like, I want to hear everything on the air with that software radio. I don't want my own oscillators, my own circuitry to cause noise. We yanked some of that stuff out of the damn RF ASIC, got it shielded away from it. I got that RF ASIC is sitting there, it's a pristine method to hear everything and make decisions on that stuff. And the whole machine learning thing, and like I was talking about with encrypted packet analysis, that whole thing of going, I know who you are, I know who you are, I know what the interference is in the air, I know everything. I'm looking to hopefully see an RF ASIC version 2 or some other things that I can't talk about that I think is really cool.
Could that be like a module, I think like a 3700?
Yeah, see, we've done, and it's kind of funny about modules. We've done modules all the way back. If you look at the AP 3600, okay, when the 3600 was made, Bluetooth did not exist. We put a module in the 3600, gave it full hyperlocation and Bluetooth after the fact, right? So we have modules on, there's always a product in our line with a module. Today it's 3800. There will be a Wi-Fi 6 with a module, right? And we're already working with partners on what we can do in that module far beyond what we're doing today with modules, and we did the dual 5, the dual 5 gigahertz, that all kind of happened based on early development with modules. We wanted to be able to do isolation, and so even things like the cellular, there was a cellular module for one of the APs at one time. We put cellular filters on the AP so that it could coexist with that. So a lot of the APs that we design, especially with the modules, they have hardware things we don't talk about. We just put it in there, and then all of a sudden we start turning things on. It's like, where'd that come from? Well, I was in there. We just didn't tell you about it. That kind of thing.
Awesome. Thank you so much.
Okay, appreciate it.
Thank you, Fred. Thank you.
Great. So this has been another great episode of Cisco Champion Radio. I want to thank all of you for joining us today, especially to Fred for sharing his insight, and Roel, Francois, and Gurpreet for sharing and for hosting today's session. Look for this episode and other episodes on iTunes and cisco.com/go/TCR. I'm Brett Shore. I played the part of today's moderator, and I'll see you next time.